Mm, I love Flappy Bird. Oh, damn, my phone died. And I gotta call my mom. Hey, Aiden, can I borrow your phone?
Yeah, of course. Here you go. Oh, shoot, dude. My phone's dead, too.
Bummer. Anyone got a charger?
I possess a charger.
I'll bet. Oh, shoot. I don't think this will work. What else do we use now?
Dude, I don't know. Oh, look. It's Miss Lula's lunch.
I know. I just feel like.
Wow, dude. She's so lucky. She sure know how to cook, huh?
How are we going to use Miss Lula's lunch to charge your phone?
I don't know. What else do we have?
Well, I have some 1 molar iron 3 chloride.
That's pretty cool. It just so happens that I have some 1 molar magnesium sulfate.
Dude, I also have some iron rods.
Iron rods. Yo, let me check
anything
my
else?
wallet. Yeah, I have some magnesium ribbon.
Dude, perfect.
That's sweet.
You know what we can do?
We can make a galvanic cell.
That's radical.
All right, so I'll take my 1 molar magnesium sulfate and pour it into this beaker. Then I'll take my magnesium ribbon and dip that right in.
And I'll take my 1 molar iron 3 chloride.
Mm-mm. Looking good.
And my iron rod.
That's how you do it.
And then all we have to do is connect it.
Heck yeah.
Wait, it's not working.
What? 0 volts?
What could we be missing?
Oh. Aiden, you silly boy. Have you not heard of a salt bridge?
Oh, dude, I forgot.
Can't believe we forgot the salt bridge. Do you think that Miss Lula's lunch could work as our salt bridge?
Dude, I think it could.
It looks very high in sodium and chloride.
Which contain the necessary ions to balance out the half cells.
Sure does.
Let's get one out.
So we have 7 minutes.
It's a tough process.
Or are we just
It
Clark's waiting. Oh my god.
is pungent. Okay, I have extracted the item. I'm carrying the item over to the cell. I am now taking the specimen from Miss Lula's lunch and bending it to fit in both halves of this galvanic cell. Hey, we have voltage. You see? I am now going to connect my phone to the galvanic cell that we created.
Careful, Sebi. The galvanic cell has 904 volts going through it. That's enough to immediately kill you.
That's a risk I am willing to take. It. I'm going in. We're connected. Work, baby!
It worked.
Oh, work, baby! Oh, it's working. You can't see. It's working, baby. You see that, baby? 21% charge.
Making a galvanic cell with Sebi and Aiden.
What is a galvanic cell? A galvanic cell is a redox reaction housed in 2 half cells. Galvanic cells produce usable energy. They have an E cell that is positive, a delta G that is negative, and a K equilibrium that is greater than 1. All of this means that it is a spontaneous reaction. As we stated, a galvanic cell is made of 2 half cells. One half cell holds the anode, which is oxidized, and the other holds the cathode, which is reducidized. What is a salt bridge? Let's find out. A salt bridge's main job is to even out the charge in both of the half cells. In doing so, it stops the buildup of charge in either of the cells. No salt bridge equals no E cell. Yay!
So what did we use in our cell? We used magnesium in the oxidation reaction. The half cell reaction is solid magnesium yields Mg2 plus 2 electrons. For the reduction reaction, we used iron. The reaction is Fe2 plus 2 electrons yields Fe solid. So what is the net reaction? The net reaction is Mg solid plus Fe2 plus yields Mg2 plus Fe solid and has an E cell of 1.930 volts.
All right, so a galvanic cell has an anode, which is our magnesium ribbon, and a cathode, which is our iron rod. As you can see here, we have our 2 beakers, one with a magnesium ribbon and surrounded by dissolved magnesium sulfate, which has magnesium 2 plus ions. The other beaker has our iron rod and is surrounded by dissolved iron 3 chloride, so it has our iron ions right there. And here's our voltmeter connected by our alligator clips. Yes, sir. And so electrons always flow in a galvanic cell from the anode to the cathode. And last but not least, we have our salt bridge, which is a hot dog. Ta-da!
Making the 1 molar solutions. For the iron solution, we used solid iron 3 chloride, which has a molar mass of 162.2 grams per mole. So for the 100 milliliter solution, we dissolved 16.22 grams of iron 3 chloride. For the magnesium solution, we used solid magnesium sulfate, which has a molar mass of 120.38 grams per mole. So for the 100 milliliter solution, we dissolved 12.04 grams. Here we are grinding up the iron 3 chloride to dissolve in the beaker. As you can see, it's a little chunky, so we had to use a mortar and pestle. Then we measured out the correct amount of grams and we poured it in 100 milliliters in our first beaker. Then we measured out our magnesium sulfate, which was already like a powder, so we didn't have to grind it, and poured it in our second beaker. Then we put the magnesium ribbon in the beaker with the dissolved magnesium sulfate and the iron rod in the beaker with the dissolved iron 3
It was
chloride.
like instant. I looked away for like 1 second.
Then we connected it to the
bridge
voltmeter and
in.
put the salt bridge in.
Yes, sir!
That was instant. Take it out.
Out. Salt bridge in.
Boom. That's
as you can see, everyone was super excited because we discovered this great scientific achievement right here at ETHS. Um, Aiden and Sebi then went on to win the Nobel Peace Prize for all the lives they saved with the discovery of the hot dog salt bridge. The world was never the same after this moment. The entire scientific community said they owed Aiden and Sebi a large debt, and we're forever grateful for our achievements. The credits don't move.